So thanks everyone for being here. I'm Vince Wu, the sales manager from Endis Technology. We are a RISC-V pure play CPU IP company. And so far we are 19 years old and we are publicly listing in Taiwan stock market. And we are contributing a lot to the software ecosystem for RISC-V and the open source. So we are the premier and founding member for RISC-V International. We are also the premier and founding member for RISC-V software ecosystem, which is the RISE. And so far, Endis has announced 30 RISC-V cores, all silicon proven, and we have 400 licenses commercially, and all of our manpower is over 500, and 80% of our manpower is R&D resource. And we have our own tool chain we call ND Site. It is IDE based on Eclipse, and we have our proven Raker by Endis customer with a global shipment, 14 billion pieces with Endis core inside. All the 30 cores are listed in this slide, and our customer has adopting Endis RISC-V core from driving on the ground for automotive, holding on your hand for mobile Wi-Fi, Bluetooth, SSD controller, and also for the IoT, MCU, MPU, and even in the cloud, we have our customer Meta. So if you are surfing the Facebook every day and you see the advertisement recommendation, remember it is done, the computation is done by RISC-V, Endis RISC-V. Thank you very much.
Hello, welcome. My name is Lukas Jünger and I'm from a company that is called Machineware. Well, I think, as you all know, RISC-V is still a very new and continually evolving instruction set architecture. So in the last year alone, 14 new extensions were added to RISC-V. And with these new extensions, you get new instructions, new registers, new things in your RISC-V processor that you can use. However, at the same time, if you fully want to leverage this technology, your software needs to support this as well. So your software needs to evolve together with the RISC-V hardware. The problem is that today, the availability of RISC-V boards for software prototyping, for software porting, is still extremely limited. And especially if you want to have the latest, greatest features, the hardware basically doesn't really exist yet. So how can you bring up your software if you don't have hardware available? Well, the answer is quite simple. There's a tool that is called a virtual platform. And virtual platforms are basically simulators of entire electronic systems. So you can run the software that you will run on your board later, earlier on a virtual platform, without any modification, without any changes. At the same time, besides this early availability, virtual platforms have a lot of other great advantages. For example, they are very scalable, so you can easily copy your virtual platform 1,000 times or 10,000 times, run it in the cloud to parallelize all your software testing. They also allow for very deep introspection, so you can press pause anytime and look exactly at what your system is doing. So these are just a few of the great advantages of simulators and virtual platforms, and if you would like to learn more about how you can leverage them in your RISC-V design, please come by our booth and let's have a conversation about that. So thank you very much.
Hello everyone, my name is Devin Sharma. I work for Test and Embedded Analytic team at Siemens EDA. So Siemens provide world's most comprehensive EDA software, hardware and consulting services. At Tessent Embedded Analytics, what we do is we provide basically a suite of RTL modules which get integrated into your SoCs, and idea is to provide you non-intrusive observation into how your SoC is behaving when you run the real-time software on it. So you can do a lot of things with it. You can do real-time debugging, you can get trace, you can do functional monitoring, performance monitoring, and you can use these monitors for in-lab analytics, and also you can use it for in-life analytic purposes as well. So you can see in the sky green colors, those are some of the monitoring IPs we have. You can use a combination of them to create a really powerful system, when it comes to analytic application. So for RISC-V core, if you are doing RISC-V development, what we can provide is an enhanced trace encoder. Basically, this allows you to trace your CPU and which is compliant to RISC-V efficient trace standard. In fact, it was Siemens who originally donated the RISC-V efficient trace specification initially, which was refined and ratified by RISC-V International. We have a unique feature of cycle accurate instruction trace. So this is just the offering exclusive to Siemens trace, enhanced trace encoder. This is not part of the standard. The beauty of this feature is it allows you to basically have observation on when the trace is happening on cycles. Yes, thank you.
Hi everybody, thank you for joining. I want to only say one thing. I would like you to join my talk at 12 today to discover this brand new board from Sci5. This is the new standard for high performance RISC-V development boards. That's a new standard with an out of order core, a quad core, with lots of peripherals, a new system on module approach, as you can see here on the picture. So please come around. You can also go to our booth to see the demo running, live demo with Linux, games, and video decoding. And that's it for now. See you later.
Hi, so welcome everyone. My name's John Taylor. I'm from Synopsys, and I'm going to quickly run through all of our solutions that run from silicon to software for RISC-V. So to start with, we have back-end quick start kits which show you reference flows for implementation on all the process nodes you can think of, including the latest sort of 2 nanometer nodes. We have a DV solution, Imperius DV, for CPU verification, including custom instructions. We have platform simulation tools that can help you with early software development or power analysis and system architecture to choose how your multi-core SoC works, and can help you with software and hardware partitioning and proving which custom instructions will help you. As you move through to verification, we can help with hardware-assisted verification, and you can use those platforms for software development as well, reducing risk, improving quality, and can do power profiling as well as software development. And then we have our own IP portfolio, which includes RISC-V IP cores from the ARC-V family, as well as a large selection of interface IP and other IP to help you get to market faster. And most recently, we've added security IP to that portfolio too. We've got several booths as well as the kiosk here, so you can talk to our colleagues around the show. And we're running a variety of talks over the next day or two as well, so I hope to see you in some of those. Thank you.
Hello everybody. Thank you for being here to know more about Tiempo Secure. My name is Michael Durac. I am the company's VP in charge of sales and marketing. A few words about Tiempo. Tiempo is a deep tech cybersecurity enabler. We are mainly providing secure IP technology core and services for any chipset, platform, SOC that is requesting embedded security. Our product and services we have 5 main pillars today. Our main core product is to provide secure enclave technology based on RISC-V CPU. This is clearly your main core product that can be a root of trust, IP secure elements, whatever you can name it. We are also providing secure IP, security and crypto IP as standalone IP, so we can deliver TRNG, IES, post-quantum IP. Around your technology, we are also to provide a complete HSM and provisioning platform to administrate the security that we embed into the system of chip. We are also able to provide the services and to operate the services for our customer. In the services part also, we are able to provide consultancy and assistance in security architecture for a chipset vendor. And last one, this is clearly one of your key differentiator, is really to provide certification as a services. So we support our customer until they get the certification of the platform. So whatever is the security standards that you want to achieve, we are able to provide assistance for common criteria, CZIP, FIP certification, or even PSA certification. Thank you.
Hi everyone, I'm Florian Collet from Technology Innovation Institute, TII for short. TII is a research center in Abu Dhabi, the capital of United Arab Emirates. We are an applied research center. We're trying to provide solutions and products for the problems of the Middle East regions. We have 10 different centers like quantum research, renewable energy, AI, and I'm personally in the Secure System Research Center, so we're interested in cybersecurity in general, from hardware to software. And in my team, we're doing SoCs, so system on chip, based on RISC-V. So we have now done Shaheen, which is our first test chip, and a month and a half ago we actually taped out Al-Sakr, which is our newest SoC. It has two CVA6 cores, Open Titan in there, it's all RISC-V based. Also a Pulp cluster, for those who know, it's RISC-V also. And right now we're working on the second iteration with more security inside. And if you want to know more about this effort, we have a booth here, and you're welcome to join.